Hello and welcome back again to the course Comprehensive Slope Stability Analysis using PLAXIS 2D. This is tutorial 37, Embankment Construction on Soft Soil, improved with jet grouting columns in PLAXIS 2D. So if you remember in previous lecture, we had the same example, same soil stratigraphy and embankment. The geometry of the embankment is the same as a previous lecture, but in the previous lecture we improved this soft soil using a stone column, but in this example we will use a jet grout columns, which is another improvement technique for modification or improving the soft soil. So first I want to shortly talk about the jet grouting. It is one of the method for stabilization or improvement of weak soil. So in this improvement technique, cement slurry is injected into a soil at a high velocity to form a soil concrete mix using a special machine. As you can see, this machine is inserted into the ground and rotated in a high velocity, and the cement slurry is injected into the ground, and so it makes like a circular shape of concrete soil matrix. So this method also, the effectiveness of this jet grouting method depends on the type of soil. For example, it is affected by nature of erodibility of a soil. For example, a gravelly soil and clean sand are highly erodible. That's why mostly effective in this type of soil, gravel or clean sand. However, this improvement method is not very effective in very high plasticity or high plastic clays because it is difficult to erode. However, it can be used in clay soil as well, but it is mostly effective in gravelly soil or sandy soil. So, in numerical analysis, the most challenging parameter to determine is the Young's modulus of jet grout, and this parameter, Young's modulus of jet grouting, is dependent on unconfined compressive strength of jet grout material, and also cement content, how much cement is inserted or added to this slurry, also age of the mixture, and also highly depends on the soil properties. So we have this figure. This figure shows us the Young's modulus elasticity of the jet grout material versus axial compression strength of jet grout material from different case studies by different researchers. So in x-axis we have uniaxial compression strength of jet grout material, and corresponding y-axis we have E50, which means the second modulus of elasticity of the jet grout material. So we can see the ranges of the modulus of elasticity from these figures, and we can see it depends on the uniaxial compression strength of the jet grout material. So we can find the modulus of elasticity in laboratory by taking a sample of jet grout material and test it under uniaxial compression strength, and also find the modulus of elasticity. However, in case when we don't have any data or laboratory data in hand, we can assume based on some correlation, such as these figures or this formula. This formula also is used to estimate the modulus of elasticity of jet grout, which is equal this coefficient, beta coefficient for elasticity, times the uniaxial compression strength of the jet grout. Both cases, this is maximum deformation in embankment for unreinforced embankment. If I click on embankment after construction of jet grouting column, we can see the displacement or total displacement is decreased considerably. So we can see it's only about 5.8 centimeter, while for unreinforced soil, the total displacement is about 15 centimeter. Also, I want to suggest you this textbook for jet grouting, for design the jet grouting. It's called Jet Grouting Technology, Design and Control by these authors. So you can find everything about the jet grouting and different case studies and material properties of jet grouting and mechanism and effect, and also the design principles and design example for the jet grouting. I will also upload this textbook under this tutorial, so you can download it easily. Okay, this was for this lecture. I hope it was useful. Thank you for watching. See you in the next tutorial.